Ladies and gentlemen, welcome to section 10.5, the Pythagorean Theorem. Before we start into the Pythagorean Theorem, there's a couple vocab words that we have to know. First one is a hypotenuse. You may have heard of this word before, but the hypotenuse is in a right triangle and is the opposite side of the right triangle or the right angle. So wherever this right angle from, this little box here denotes that this angle is a right angle. The side opposite of that would be the hypotenuse. So both of these are the hypotenuse. Now moving on to the legs are the two sides that form the right angle. So the legs that come in here to make up this right angle are the legs. So this is a leg, here's a leg, here, and here's also a leg. So let's take a look at the Pythagorean Theorem. And with words, the Pythagorean Theorem states, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs A and B, so we're going to let the legs be A and B, equals the square of the length, or the square of the length of the hypotenuse C. So hypotenuse, remember, is across from the 90-degree angle, and that is going to be the sum of both of these squares, or it's stated right here. And ladies and gentlemen, this is huge. A squared plus B squared equals C squared. A squared plus B squared equals C squared is the Pythagorean theorem. This is what we are going to be using today. A squared plus B squared equals C squared. C squared will always be the hypotenuse. C will always be the hypotenuse. So let's take a look at some of these problems. We're asked to find the unknown length for the triangle shown. We are asked to find A. So we do not know what A is. Remember, here's the Pythagorean theorem. We do not know what A is, so I'm just going to leave A squared. And then I'm going to plus, what's my B? My B is 6 squared equals, my C is always by itself on one side of the equal sign. Now we just have to simplify this mess, so it's A squared plus 36, that equals 7 squared is 49. Now to solve for A squared, I'm going to subtract this 36 over and then bring down my A squared equals 13. How do you get rid of the square? Please remember that we have to square root to get rid of a square. So A equals the square root of 13, or in decimal form it's going to be 3.6 for our final answer. So A is 3.6. Jumping to number 2. Now we know what A is, we don't know what B is. C is 9. So using Pythagorean again, we have A is 4 squared plus, we do not know what B squared is, and then C is always by itself, 9 squared. Now ladies and gentlemen, it really doesn't matter if you switch up A and B, but C does have to be all by itself. So moving forward with this, 4 squared is 16 plus B squared, that equals 81. Subtracting 16 over to the other side, B squared equals 65. How do you undo a square? You have to square root both sides. So B equals the square root of 65. So this would be a legal answer, or the square root of 65 equals 8.1 for your final answer. 3, how about? Now we are given A and B with no C. So A and B have to go on the same side. 6 squared plus 7 squared. Now if you want 7 squared plus 6 squared, it would be the same thing, ladies and gentlemen. It's exact same thing. That equals C squared. Simplifying, 36 plus 49, that equals C squared. C squared now equals 85. And then C, how do we get C all by itself? We have to square root both sides, so C equals 9.2 for your final answer. Now with some more vocab words. Now we have the converse of the Pythagorean theorem, which states if the sides of a triangle have lengths ABC and C squared equals A squared plus B squared, then the triangle is a right triangle. So moving on to Pythagorean triple is numbers that satisfy the Pythagorean theorem. You'll see that here in a little bit. And so now we are going to be asked, tell whether the triangle with the given sides is a right triangle, then determine whether they form a Pythagorean triple. what we're going to do with these numbers, we're just going to plug them in here. So if they equal each other, if this side equals that side, then we know that it is a right triangle and whether it is a Pythagorean triple. So let's go ahead and try it. We have an A, we have the B, and the biggest number though, ladies and gentlemen, the biggest number will always be your C. All right? Again, I repeat, ladies and gentlemen, the biggest number will always be your C. So let's go ahead and try this. We have 8 squared plus 15 squared. That equals 17 squared. So then 64 plus 225, that equals 289. So does it? Let's add this up. This adds up to 289. Well, the other side equals 289. So that equals each other, which is a good thing. So tell whether the triangle with the given sides is a right triangle. Yes, it is a right triangle. Yes, right triangle. And then whether they form a Pythagorean triple. Yes, to a triple. One more example here. Now we have 18, 24, 30. Which one is your C? That's the only thing we have to find out. The biggest one, which is 30, is C. So now we just plug in the rest. This is A, this is B. Or you could have B, then A. It doesn't matter. I'm going to put 18 for my A squared plus 24 squared equals 30 squared. If you want to go 24 squared plus 18 squared, see if you get the same thing, by all means, please do it. So 18 squared is 324 plus 576. Does that equal 900? Well, these add up to be 900. You guessed it, which equals 900. So again, we have a right triangle and a Pythagorean triple. And that does it for section 10.5, the Pythagorean theorem. Good day.